Welcome to aminacademy.com. In strength of material regarding elastic constant, let us discuss about volumetric strain of a cylindrical rod. Look at this figure. Here, the in solid cylindrical rod, force P is applied axially. Due to that tensile force, there is a increase in length, that is L plus delta L, and as well as decrease in diameter, which become d minus delta d. Now we'll start the problem. Let d diameter of rod, L length of rod. Load P is applied. Then for that, due to application of the axial load P, therefore it becomes final length after application of load, final length equal L plus delta L, and final diameter is d minus delta d. Because while pulling this side, there is a compressive force in perpendicular to the axis. Now original volume pi by 4 d squared L. Final volume is pi by 4 d become d minus delta d, that square, L become L plus delta L. Now we'll expand this. Pi by 4, first d minus delta d whole square equal to d square plus delta d square minus 2d delta d into L plus delta L. Now we have pi by 4. This expansion becomes d square L, because we are multiplying with d square L, d square delta L, like d square L plus d square d square L minus 2dl delta d plus d square delta L plus d square delta L minus 2d delta d into delta L. Here, neglecting the products of powers of small quantities, powers of small quantity. That means we have to neglect delta d delta L and delta L delta d. We have to neglecting. It becomes simplicity like pi by 4 d square L minus 2dl delta d plus d square delta L. Now change in volume. Now change in volume, we are having final volume by original volume. Here this final volume is this expression, and original volume minus, that is pi by 4 d square L minus 2 delta L d square L minus 2d, here not delta, this minus 2d into delta d, 2d delta d d square L minus 2d L 2d into L comes 2d L d square L 2d L into delta d plus d square L d L delta d, d square minus 2dl minus 2dl delta d minus 2dl delta d plus d square delta L minus pi by 4, the original volume is d square L. So collecting pi by 4, so we have d square L and d square L cut, so we have the simple d square L d square delta L, because d square L cut, d square delta L minus 2d into L delta d. Therefore volumetric strain equal EV, change in volume by original volume. Therefore change in volume is pi by 4 d square delta L minus 2 dl delta d over V is pi d square L, pi by 4 d square L, that pi by 4 cut, and here we'll splitting delta L by d square L minus 2 dl delta d by d square L, so which gives delta L by L minus 2 times delta d over d. Here where delta L by L is the strain, of diameter, strain in diameter. So strain of diameter. Therefore, volumetric strain we can express volumetric strain equal strain in length minus twice the strain in diameter minus twice the strain in diameter. This is a final expression. That means volumetric strain of a cylindrical rod is equal strain in length minus twice the strain in diameter. We have done. Please subscribe our YouTube channel.